All right, hello there guys. We're going to go through and find the area of some basic shapes. So the first shape we have here is a parallelogram. The formula for the area of a parallelogram is base times height. A key thing to note on quite a few of these shapes is that your base and your height, they must be perpendicular. Okay, so your base has to be perpendicular to their height, meaning that they're making a right angle. So here, this 4.4, this is our base, okay? And it's not the base because it's on the bottom of the shape. It's the base because it is one of the sides of our parallelogram. Now, the height of our parallelogram is not the other side of our parallelogram. It's actually in this line here, this 6.6, because as you can see, the base and this line, they're making a right angle. So that is your base and your height for the parallelogram. So to find the area, we just do 4.4 times 6.6. So 4.4 times 6.6, and it is 29.04, and it would be centimeters squared. Okay, next one we have here. It's another parallelogram. Again, we have to find our base and our height, and they're going to be perpendicular to each other. So look for that right angle. So here's the right angle, here's the height, and then your base is this side right there. And on a parallelogram, remember, your opposite sides are congruent, so this is also 34. So our area would be base times height, so 34 times 39. Which would be 1,326. And it's inches squared. Okay, next one here. This is a triangle. The formula for the area of a triangle is base times height divided by 2, or 1/2 base times height. Okay, so again, your base and your height are at a right angle, so look for that. So there's our base and our height. So for this one, it's going to be 19 times 3 divided by 2. So 19 times 3, divide that by 2, and you will get 28.5 centimeters squared. And again, that base and the height, always at a right angle. Okay, this one, this is another kind of triangle you will see here. Again, look for that right angle. In this triangle, your height is not this other actual side of the triangle. It's this dashed line out here. If you remember, we talked about altitude, okay? So sometimes the altitude is outside of your triangle, and that's this case right here. So area is base times height divided by 2. So our base is 4.7. Our height is 3. Divide that by 2. So 4.7 times 3, divide by 2, and we get 7.05 centimeters squared. Okay, continuing on. Now we've got a couple word problems here. It says, a parallelogram has sides measuring 16.6 meters and 34.5 meters. Okay, so here's a parallelogram. And it says one side is 16.6 and the other one is 34.5. Okay, it says the height corresponding to the 16.6 meter base is 9.6 meters. Find the height to the nearest tenth of a meter corresponding to the 34.5 meter base. Okay, in parallelograms, you have two different sizes of sides, so you can have two different heights. And so the way that this works is you have to remember your height is perpendicular to the actual base. Okay, so here, this 34.5 meter side, the height for it is going to be right here. Because if I made a 90-degree angle to that base, I drew the line straight across, then it would go like this. And so that's going to be the height of it, okay? Now for the 16.6 meter side, the height of a parallelogram is going to look a little bit different. It's going to kind of go like how we had on the one higher up, okay? So let me kind of show it another color here. So what you got to do is you kind of extend this thing here, and if you make a right angle, you'll go and it'll attach up here. So the height for our 16.6 meter side would be here. You can also look at it like this. So let's say we turn the parallelogram. Okay, if you drop that line straight down, make that right angle, okay, that would be the height. So this would be the 9.6. And now we've got this other side here that's 34.5. And we're trying to find the height here. Okay, so with that being said, if you take the base and the height that go together, so the 16.6 goes with the 9.6. If you put that into the area formula, you're going to get that one number. Okay, now we also have to be able to calculate the same area by using our other base with its matching height. So first thing we do, calculate the area base times height using the two that we are told go together. So the 16.6 is the base, and they said the height when you're using that one is 9.6. So do 16.6 times 9.6, and you get 159.36. Okay, now in order to find out the height when we're using the other base, we're going to have to actually solve the area formula. So the area is base times height, but they've given us, we know the area, we know the base, and now we need to find the height. So we have to solve this for height. So how do I get height alone? Well, I have to divide out the base. So the height of my parallelogram would be the area divided by the base. We're just working it backwards. So I take the area, 159.36, and then I'm going to divide it by that base that they want us to use. So divided by the 34.5. So divide by 34.5. And we will get 4.61. And then when it's rounded to the nearest 10, so it's going to be 4.6. So basically, you take the base and the height that they give you, find the area using that, and then you divide by that other base that they give you, which would tell you the matching height that goes with it. Okay, next thing here, it says the area of a parallelogram is 480 centimeters squared, and the height is 40. Find the corresponding base. Okay, again, area, base times height. They tell us the area is 480, and they tell us the height is 40, and we need to find the base. So we're just solving this for the base. So do 480 divided by 40. 480 divided by 40. So the base is 12, and it would be centimeters. Okay, number 7. This is continuing in the same concept with parallelogram. Don't let all the dashed lines get you confused. If you ever need some help, just go and trace all the solid lines first. That's our shape. So we have a parallelogram, and we've been given some measurements on it, and they're asking us to find this height over here. So same thing applies. We have to use the base and the height that go together to find the area. So area is base times height. And right now I can see this height here in blue, the 5, is going to go with this base here. And again, the top is 13, so this bottom side is also 13. So you have to do 13 times 5. Okay, so 13 times 5, 65. So the area total is 65. Now what they want us to do is use the 7. Okay, so that's our base. And now to find the height, we have to have this thing here that's at a right angle to it. Okay, remember the 7's also over here too. So see, the base and the height, they make a right angle. Okay, so we take the area, 65. We know the base is 7, but we don't know the height. So just divide by 7. So 65 divide by 7. And it gets you 9.28. And again, I want to round this to the nearest tenth. Okay, so it would be 9.3. And that would be whatever units they have. Okay, next thing here, area of a trapezoid. I'm going to come back to question number 8. Okay. Okay. I'm going to do this one here that's a little bit simpler first, and then we're going to go back up there. So this is a trapezoid. All right, and the area for a trapezoid is base 1 plus base 2 times the height, and then you divide by 2. So your bases are these parallel sides, okay? And it doesn't matter which one you call base 1 and which one you call base 2. It's interchangeable. So, and then your height, again, is going to be perpendicular to the bases. So this right here is your height. The 13 is there to confuse you. Remember, your height is not slanted, okay? It's always perpendicular. So we just plug in. So 9 plus 19 times 11, and then divide by 2. We're going to label here. That's base 1, this is base 2, and this is your height. So we just type this 9 plus 19, 28, times 11, divide by 2, and you will get 154, and it will be inches squared. Okay, now we will go back up here to number 8. Okay, number 8, you have to be careful. It just says find the area of the trapezoid. Okay, now it's very important here, you have to pay attention. It says not drawn to scale. Okay, so you cannot just make assumptions based on what the picture looks like. All right, right now it looks like these two slanted sides, the legs, it looks like they are the same. However, you have to use this 45 here, and this will help us on number 10 as well. You see this 45 and this 90? That means this over here is also 90. So on the left-hand side, we have this triangle. It's a 45, 45, 90. Remember, on a 45, 45, 90, you have x here, you have x there, and then you have x square root 2. So you've got to be careful. Don't just go and assume here, because a lot of people will make the assumption, oh, this little part right here is 4 centimeters, so this part over here must be 4 centimeters. Well, again, it's not drawn to scale, and they have not put the markings on the legs to tell us that this is an isosceles triangle, or I'm sorry, an isosceles trapezoid. So we have to go and use the fact that this right here is a 45-degree angle so that we can know what this section would be. So with that being said, here, this is going to be 6 centimeters, this height part. So that means since this is a 45, 45, 90 triangle, that means this little piece right here is also going to be 6. Because remember, on a 45, 45, 90, your two legs are the same. So now, base 1, I'm going to call it the top up here, base 1, that's 10. Base 2 is these three sections that we have to add together. Here, this is 90 up here. So here, this is going to be 90 as well. So this is a square. And so this, if this part is 10 up here, this part down here is also going to be 10. And then the next section is 4. So we have a 6 plus a 10 plus 4. So 6 plus 4 is 10 plus another 10, so it's 20. So that's our base 2. And then our height is right here, perpendicular to our base, it's 6. So now the area. Base 1 is 10, base 2 is 20, times the height, divide by 2. So 10 plus 20, that's 30, times 6, divide by 2, and you will get 90, and it's centimeters squared. Okay, next trapezoid here. Again, 45, 45, 90. Be careful. This part right here is 10. So this section right here is going to be 10. And we can see the whole side down here is 18. So that means this part is 8. Since this is a 45, 45, 90 over here, that means that this height will also be 8. Okay, so the area base 1 is 10. Base 2 is that 18 because it's got to be the whole side. And then your height is 8. Now I got that 8 down here on the bottom because I said the whole side here is 18, but then we go here and we have to cut off 10. So 10 plus what gives me 18? 8. Okay. So now, and also I made note that it's a 45-degree angle here. It's a 90 right there. So that means this is also 45 there, which makes the two legs equal, which is how I got that height. So area, base 1, 10, base 2, 18, times the height, which is 8, divide that by 2. So 10 plus 18 is 28, times 8, divide by 2, gives us 112. That's feet squared. Okay, next one. Okay. Our next shape that we're going to cover is the kite. Okay, the area for a kite, it's diagonal 1 times diagonal 2, divide by 2. So on a kite, if we look here in the picture on number 12, there's one diagonal. It goes from one corner to the opposite corner. And then we have our second diagonal. So you just take the two diagonals, you multiply them, and divide by 2. So it says a kite has diagonals of 8.2 and 9. What is the area? Okay, so 8.2 times 9, divide by 2. So 8.2 times 9, divide by 2, gets you 36.9 feet squared. Okay, next one here. On this one, the diagonals, they're given to us in pieces. So diagonal 1, I'm going to do the vertical one. It's 3 plus 9, so it's 12. Diagonal 2, the horizontal one, 3.5 plus 3.5, so it's 7. So the area will be 12 times 7, divide by 2. So 12 times 7, that's 84, divided by 2, you will get 42. So it's 42 feet squared. Last few. Rhombus. Rhombus is the same thing as a kite. Diagonal 1 times diagonal 2, divide by 2. Diagonal 1, 9 plus 9, you have to add both sections. Diagonal 2, is also 9 plus 9. Okay, so 18 times 18, divide by 2. 18 times 18, divide by 2, we get 162 meters squared. So that's a rhombus. Okay, last part now. Now we're on to circles. Okay, circles, we did this last week, but this is just a refresher. So area is pi r squared. And remember, r is the radius, which is only halfway, so from the center to the edge. So for this one, we have pi times 6 squared. So this is 36 pi. And they say we want to have use our calculator's value of pi and round to the nearest 10. So I do 36 times pi, enter, and I get 113.09. So that will round to 113.1. And it's feet squared. Next one. This one, again, same thing, except this time, instead of the radius, they've given us the diameter. So to find the radius, it's the diameter divided by 2. So I have to do 23.2 divide by 2 first. So 23.2 divide by 2, get 11.6. Now, area is just pi times 11.6 squared. So 11.6, square it, times pi. You get 422.73. So it's 422.7 miles squared. Next one here. This is a quarter circle. So it's 1/4 of a circle. So you just take the area of a circle, so pi r squared, and you only want 1/4 of it, so you divide by 4. So pi times 7.4 squared, divide by 4. So 7.4 squared times pi, divide by 4, and you will get 43, and it's 0.008, but we only want the 10th, so it's just 0.0, and it's inches squared. And then our last kind that we have, a semicircle, okay, it's just area pi r squared, divide by 2, because it's half. So, and again here, our radius is diameter divided by 2. They give us the diameter because it's all the way across. So you have to do 8.8 divide by 2. 8.8 divide by 2, 4.4. So you have pi times 4.4 squared and divided by 2 because we only want half the circle. So 4.4 square it times pi, divide by 2, and you get 30.4, and it's meters squared. All right, guys, so that's all there is to it. That's just simple, straightforward area of simple shapes. And see you guys next week.